Hello everyone, today we are going to analyze this 3D truss. We have to find all of the member forces in this truss. This is the 3D view of the truss and this is the top view. This is the x-axis, this is the y-axis and it is the z-axis. In the top view, we cannot see the load in the y-axis. Also, we can't see the reactions in the y-axis. We need to find these reactions. You can see that in the Z direction, there is only one reaction, BZ. Since there is only one, we can find it very easily. We have to use this rule, summation of FZ is equal to 0. We can keep this way as positive and the opposite way as negative. So this one will be positive and this one will be negative. For BZ, we will get 40 kilonewton. To find Cx, we can take movement about to B in the y direction. For making the process a little easy, in the point B, in the y direction, we can make a line. When we take movement in the y-axis, we should not consider any load or reaction in the y direction. So this load, this reaction, and this reaction we should not take. Also, anything along this line we should not consider. So Bx and 40 kilonewton we should not take. Now only there is two remaining, this 40 kilonewton and this Cx. Let us keep clockwise as positive and anti-clockwise as negative. This one about the point B is acting in the anti-clockwise direction. So it will be negative and the distance is 5. So minus 5 Cx. We know that this load 40 kilonewton is in the center and in the top. This load about this axis will be acting in the anti-clockwise direction. So it will be negative and the distance is half of AB, that is 4 by 2. It will be 2 meter. So minus 40 into 2, it is very easy when we look at the top view. This one is acting in the anti-clockwise direction, so it will be negative and the distance is 5. So minus 5 Cx. This one about B also is acting in the anti-clockwise direction, so it is also negative. This is the distance, that is 4 by 2, so it will be 2. In this way for Cx we will get minus 16 kilonewton. We have got a negative value, that means the assumed direction is incorrect. Cx is not acting in this way, it is acting towards this direction. We have to change the direction. Here you can see that I have changed the direction. By applying this rule, we can easily find Bx. We can keep this direction as positive and this direction as negative. This is positive and Bx is negative. For Bx, we will get 16 kilonewton. Let us take a movement about to B in the Z direction. Here also it will be very easy. If we draw a line along the point B in the Z direction, when we take a movement in the Z direction, we should not consider any load and reactions in the Z direction. So this 40 kilonewton and this 40 kilonewton we should not take. Also, we should not take anything along this line. So this one, this one, this one and this one we should not take. Now there are only two remaining, AY and this AT. AY is acting in the clockwise direction, so it will be positive and the distance is 4. So 4AY. About this line, this 80 kilonewton is acting in the anti-clockwise direction, so it will be negative. We know that this load is acting in the center, so from the center to this line the distance will be 4 by 2, so it will be 2 meter. For AY we will get 40 kilonewton. Now about the point B in the x direction, we can take a movement. Along the point B, we can draw this line in the x direction. When we take movement in the x direction, we should not take any load or reaction in the x direction. So we should not take this one and this one. Also along this line, we should not take anything. So this 40 kilonewton By and this 40 we should not take. Now there are three remaining, Cy, this 80 and this 40. Cy is acting in the clockwise direction, so it will be positive and the distance is 5. So 5 Cy. 80 kilonewton is acting in the anti-clockwise direction, so it will be negative. We know that this load is acting in the center. From the center, we need to find this distance. We know that the total distance is 5, but we need the half distance, which is 5 by 2. So it will be 2.5. This load is acting in the clockwise direction, so it will be positive. For this load, about this line, the perpendicular distance is the height, which is 3 meter. For Cy, we will get 16 kilonewton. Let us apply this rule and find By. Let us keep this as positive and downwards negative. These three are positive and this one is negative. In this way, for By, we will get 24 kilonewton. We have found all of the reactions. Now we need to enter the coordinates. I'm going to keep the origin at point D. It is up to you. You can keep anywhere the origin. For me, it is comfortable to keep at D. But as I said, it is your choice. You can keep anywhere. You will get the same answers. Here we have everything 0, x, y and z. In the joint C, x will be 4, z will be 0 and y will be 0. At A, x will be 0, y will be 0 and z will be 5. At B, x will be 4, y will be 0 and z will be 5. Now let us go to the top E. We know that it is at the center. So x will be 4 by 2, so it will be 2. The height is 3, so y will be 3. Z will be 5 by 2, so it will be 2.5. To find the member forces, I am going to use method of tension coefficients. These are the sign conversions. This is the sign conversion in the x-axis. This is for z-axis and this is for y-axis. In the joint D, we have three member forces, DE, DC and DA. All three of them are zero force members. Let us see how to find that. First, we have to apply the rule sigma Fy is equal to 0. We know that when we apply this rule, we have to only take the members which are in the y direction and also the inclined members. We cannot take dA because it is purely in the z direction. Also, we cannot take dC. It is purely in the x direction. Only one member we can take, that is dE. It is an inclined member. If there is only one member available and there is no other load, that member should be taken as 0. So FDE will be 0. Now we can apply the rule sigma Fx is equal to 0. This one we should not take because it is purely in the z direction. This only we can take because it is in the x direction. So when we apply this rule, there is only one member. In this case, FDC will be equal to 0. Now we can apply the rule sigma Fz is equal to 0. In the z direction, there is only one member, that is dA. We know that if there is only one member, that will be 0. So FAD will be equal to 0. So all three of these members are 0. Let us take the joint A and to find the tension coefficients. First, let us apply this rule. We have to multiply the distance of every member in y direction with their tension coefficients and then we have to add them. Also, if there is any reaction or load, that also we have to add. Then we have to equate the total addition to 0. In the joint A, no need to consider the member AD because it is 0. So only we have to take the members AB, AC and AE. Also, we have to look if there is any vertical load or reaction in the y direction. You can see that in the y direction there is a reaction 40 kilonewton. In the 2D frame analysis, we usually keep upwards as positive and downwards as negative in the y direction. Here also we can follow the same. This reaction is acting upwards, so it will be positive. The member AE is acting upwards, so it is also positive. For the members AC and AB, there is no vertical distance. In this case, we can either apply positive or negative sign. Anyway, they are going to become zero, so no need to worry. The distance of AE in the y direction is 3 minus 0, so it will be 3. In this way, for TAE, we will get minus 40 upon 3. Let us apply this rule. We have to multiply the distance of every member in the x direction with the tension coefficient of the same member. Also, we have to add any reaction or load in the x direction. Then we have to equate the summation to 0. At A, there is no load or reaction in the x direction. So we have to take only the members AB, AC and AE. Let us see how to understand the sign conversion. In the middle, we can draw a perpendicular line, which is the z direction. If you take the joint A, this is the reference line. We can keep this side as positive and this side as negative, but it is up to you. You can interchange. Right now, all of the members are in the positive side. That is why I have kept all these three terms as positive. The distance for AC in the x direction is 4 minus 0, so it will be 4. The distance in x direction for AB is 4 minus 0, so it will be 4. And for AE, it is 2 minus 0, so it will be 2. We have already found TAE, we can apply that. That is why there is a negative sign. Finally, we will get this equation. Now let us apply this rule. We have to multiply the distance of every member with the tension coefficient of the same member, and then we have to add any reaction or load in the z direction, then equate the summation to 0. In the joint A, there is no load or reaction in the z direction. For the sign conversion, we can draw a perpendicular line in the x direction like this. If you take the joint A, this is the reference line. We can keep this side negative and this side as positive. As I told earlier, you can interchange, it is up to you. The members AC and AE are in the negative side. So both of these two terms are negative. The member AB is in the same line. For this member, there is no distance in the z direction. So we can keep it either positive or negative. Anyway, it is going to be 0, so no problem. The distance of AC in the z direction is 5 minus 0, so it will be 5. And the distance of AE is 5 minus 2.5, so it will be 2.5. We know the value of TAE, we can apply that. For TAC, we will get 20 upon 3 kilonewton per meter. Let us take this equation. In this equation, for TAC, we can apply 20 upon 3. So TAB will be equal to 20 upon 3 minus 20 upon 3. In this way, TAB will be 0. Now let us take the joint B. And first let us apply this rule. In the joint B, no need to consider the member AB because it is a zero force member. We have to only take the member BC and the member BE. Also, we have to check if there is any load or reaction in the y direction. There is a reaction in the y direction, 24 kilonewton. It is acting upwards, so it will be positive. TBE is acting upwards, so this term will be positive. For the term BC, there is no vertical distance. So for this term, either we can apply positive or negative. Anyway, it is going to be 0. The vertical distance of BE is 3 minus 0. So it will be 3. For TBE, we will get minus 8 kilonewton per meter. Now let us apply this rule. We know that when we apply this rule, we have to keep the x direction as a reference. So for the joint B, this is the reference line. Here we can keep negative and here we can positive. Right now both of the members are in the negative side. So both of these two terms should be applied as negative. And then we have to check if there is any load or reaction in the z direction. There is a reaction in the z direction, 40 kilonewton. Since it is acting this way, it should be taken as negative. So minus 40. The distance of BC in the z direction is 5 minus 0, so it will be 5. And for BE, it is 5 minus 2.5, so it is 2.5. We know the value of TBE. We can apply that. For TBC, we will get minus 4 kilonewton per meter. Now let us take the joint C. In the joint C, we have found everything except the member force in CE. Using this rule, we can easily find that for BC and AC, there is no vertical distance. So these two terms will become 0. For CE, the vertical distance is 3 minus 0. So it will be 3. Also, we need to check if there is any reaction or load at C in the vertical direction. You can see that there is a reaction. It is acting upwards, so it will be positive. For TCE, we will get minus 16 upon 3. We have to find the length of the members. Some of the length of the members are given in the question. Length of AB and length of CD is 4 meter. Length of AD and length of CB is 5 meter. To find the other lengths, we can either use Pythagoras theorem or we can use this formula. Using this formula for the length of AC, we will get 6.403 meter, and for the length of AE, we will get 4.387 meter. Point E is located in the center, so the length of ED, length of AE, length of CE, and length of BE will be same, and it will be 4.387 meter. Now we have to make this table. In the table, first we have to enter all of the members. Then we have to enter all of the tension coefficients. Some of them are zero force members. For them, just we have to write the tension coefficient members as 0. When we multiply the tension coefficient with the length, we will get the forces. If the forces are positive, they will be tensile, and if they are negative, that will be compressive. Let us do one more numerical. In this numerical, in the joint E, there are 3 loads, 20 kilonewton in the x direction, 80 kilonewton in the y direction, and 40 kilonewton in the z direction. First, we have to find these reactions. In the z direction, there is only one reaction, so we can easily find that. Let us keep this side as positive and the opposite side as negative. So this will be negative and this one will be positive. For BZ, we will get 40 kilonewton. Let us take a moment about B in the y direction. Along the point B, we have to draw a line in the y direction. When we take movement in the y direction, we should not take any load or reaction in the y direction. Also, along this line, we should not take anything. There are 3 remaining, 40 kilonewton, 20 kilonewton and Cx. Same like the previous numerical, it will be easy when we look at the top view. When we take movement in the y direction, Cx is acting in the anti-clockwise direction about the point B, and the distance is 5, so minus 5 Cx. This 40 kilonewton is also acting in the anti-clockwise direction, so it is also negative, and the distance is half of AB, so 4 by 2, it will be 2 meter. This 20 kilonewton is acting in the anti-clockwise direction, so it is also negative, and the distance is half of AD. 5 by 2, it will be 2.5 meter. For Cx, we will get a negative value. That means the assumed direction is incorrect. We have to change the direction of Cx. You can see that I have changed the direction of Cx. Now using this rule, we can find bx. Let us keep this side as positive and the opposite side as negative. So these two will be negative and this one will be positive. In this way for bx we will get a 6 kilonewton. Now let us take moment about A in the z direction. We need to draw a line in the z direction along the point A. Then it will be easy to take a moment. We know that when we take movement in the z direction, we should not take any load or reaction in the z direction. So this one and this one we should not take. Also along this line we should not take any of the reaction and load. So these two we should not take. One more thing, we cannot take these two because these two cannot rotate the member in the z direction. In other words, we can say about this line for both of them, there is no perpendicular distance. You can see that. Now we can see how many are remaining. This 80 kilonewton, 20 kilonewton and this By. So totally 3 are remaining. By is acting in the anti-clockwise direction about this. And this is the distance we have to take. This distance is 4 meter. So minus 4 By. This load is acting in the center and it is acting in the clockwise direction about this line. So it will be positive. We have to take this distance, half of 4 meter. So it will be 2 meter. This 20 kilonewton is acting in the anti-clockwise direction. So it will be negative. For this load, the perpendicular distance about this line is the height, which is 3 meter. For By, we will get 25 kilonewton. Now let us take a moment about B in the x direction. We have to draw this line along the point B in the x-axis. We know that when we take moment in the x direction, we should not take any load or reaction in the x direction. So this 20 kilonewton, 26 kilonewton, 6 kilonewton we should not take. Also along this line we should not take anything. This one and this one we should not take. There are only 3 remaining, dy, 40 and 80. About this, dy is acting in the clockwise direction, so it will be positive and the distance is 5. So 5 dy, 40 kilonewton is acting in the clockwise direction, so it will be positive. About this, the perpendicular distance of 40 kilonewton is the height, which is 3 meter. So 40 into 3. This load 80 kilonewton is acting in the anti-clockwise direction, so it will be negative. It is acting in the center. From the center, we need this distance. Totally, it is 5. So 5 by 2, it will be 2.5. For dy, we will get 16 kilonewton. Let us apply this rule and find out ay. Let us keep upwards as positive and downwards as negative. These three are acting upwards, so all three are positive. And this is acting downwards, so it will be negative. For ay, we will get 39 kilonewton. Now we can enter the coordinates. In this numerical also, I am going to keep the point D as the origin. From the point D, we can measure the distances and write the coordinates. By applying the rule sigma Fy is equal to 0, we will come to know that the member force CE is 0. And then by applying the rule sigma Fz is equal to 0, we will come to know the member force in CB is 0. Let us take the joint A and first let us apply this rule. For AD and AB, there is no vertical distance. So both of these two terms will be 0. If you know this concept very clearly, no need to write these two terms and waste the time. You just take the members which have the distance. The vertical distance of AE is 3 minus 0. So it will be 3. Then we need to check if there is any load or reaction in the vertical direction. There is a reaction in the vertical direction. It is acting upwards. So it should be taken as positive. In this way, for TAE, we will get minus 13 kilonewton per meter. Now let us apply this rule. For AD, there is no distance in the x direction. So this term will be 0. We know that along the point A, we have to draw a reference line. This side positive and this side negative. AB and AE are in the positive side. So both of these two terms will be positive. The distance of AB in the x direction is 4 minus 0, so it will be 4. And for AE, it is 2 minus 0, so it will be 2. We know the value of TAE minus 13. Let us apply that. That is why there is a negative sign. For TAB, we will get 6.5 kilonewton per meter. Now let us apply this rule. For AB in the z direction, there is no distance. So this term will be 0. We know that in the point A, along the x direction, we have to draw a reference line. And we have kept initially, here it is negative and here it is positive. Both the terms AD and AE are in the negative side. So both of these two terms are negative. The distance of AD in the z direction is 5. And for AE, it is 2.5. We know the value of TAE. Let us apply that. For TAD, finally we will get 6.5 kilonewton per meter. Now let us take the joint B. In the joint B, first let us apply this rule. For AB and BD, there is no vertical distance. So these two terms will be 0. At B, we have a vertical reaction. It is acting upwards, so it will be positive. The vertical distance of BE is 3. For TBE, we will get minus 25 upon 3 kilonewton per meter. Now let us apply this rule. For AB, there is no distance in the z direction, so this term will be 0. At B, in the z direction, we have a reaction 40 kilonewton. It should be applied as negative. Along the joint B, we can draw a reference line. Both of the members BD and BE are in the negative side. So both of these should be applied as negative. Then we have to apply the distances. We can apply the value of TBE. For TBD, we will get minus 23 upon 6 kilonewton per meter. Let us take the joint C and let us apply this rule. At joint C, in the x direction, we have a reaction. Since it acts this way, it will be positive. We know that along the point C, we can draw a reference line like this in the z direction. This side positive and this side negative. The member CD is in the negative side, so this term will be negative. The distance of CD in the x direction is 4. For TCD, we will get a 6.5 kilonewton per meter. Let us take the joint D. In the joint D, only we have to find TDE. The rest we have calculated. In the joint D, in the y direction, there is a reaction. It is acting upwards, so it will be positive. Except DE, there is no vertical distance for other members, so all three are 0. For TDE, we will get minus 16 upon 3 kilonewton per meter. We have to find the length of the members. Some of the lengths are given in the question. For the length of BD, using this formula, we will get a 6.403 meter. And for length of AE, we will get a 4.387 meter. Length of DE, length of BE, length of AE and length of CE will be same and it will be 4.387 meter. We need to multiply the tension coefficient with the length of the members so that we will get the forces. Now we are going to end this session. Thank you for watching this video.